So first, Schemitt trigger, it is one of the closed loop system. How it is compared with the closed loop system means the output is connected to the minus means normal closed loop operation amplifier. The Schemitt trigger means output is connected to the input on the plus terminal. Output is connected to the plus terminal. That means feedback is a what type of feedback means positive feedback. It is connected to the plus. That is the one difference from the closed loop of the operational amplifier and the Schemitt type of that operational amplifier. Coming to the point number next 2. So you can see as per the circuit diagram, we are going to make the circuit connection as per the circuit diagram. So it is a one of that one signal giving the input, okay, to the minus terminal you are giving. So source is connected to the which place? Minus place is connected to the source. If source is connected to the minus place means what is output? Output is a okay inline or 180-degree phase shift. Source is connected to the minus, so it is inverting, okay, inverting input. So 180-degree phase shift output is produced. That's all. 180-degree phase shift output is produced. So we're going to make the connection as per the given the circuit diagram. We'll do the connection on the breadboard. Okay, here you will going to use one resistance, another resistance, another resistance, 3 resistance you will going to connect it. This is operational amplifier. What is operational amplifier? It's a famous voltage 1741 operational amplifier we're going to take. What is operational amplifier connection diagram? This is a connection terminal point is a 2, connection terminal 3, another this is a point is a 6. So 2 and 3 is the input, 6 is output. So here is a operational amplifier. You want to give plus VCC, minus VCC or minus VEE. So here is a plus 12 volt and a minus 12 volt you want to apply. That's all. So how many terminal you want to use? 1, 2, 3, 4, 5. Only 5 terminals. But it's a dip package. Dip package means 8 pin. So 8 pin means 8 pins are available. But how many pins you are use? 1, 2, 3, 4, 5. Only 5 pins are used. What are the 5 pins? So pin number 2, pin number 3, pin number 6. Output pin is the 6th pin. Okay, 7th pin is called the VCC. 12 volt you will going to apply, and the minus VCC you will going to apply for that one. Okay, 4th pin. Okay, that's all. So negative we will going to give that one common, that one negative we will going to give from that one from the source. So coming to that one, you will going to make the circuit diagram. What you will going to do here? So here is a function generator you are going to use. So function generator used to, you will going to give the input on the minus place. So if you are going to give the minus place means 180-degree phase shift output is produced. So here you will going to give the sine waveform, you will going to give the input. The output it will going to produce. What is output is produced means square waveform is produced. That's all. This is the output. So you will going to use the CRO. Okay, in the pin number 6 with respect to the ground, you will going to measure the CRO. Okay, you can connect the CRO to see the square waveform. However, the output will come 180-degree phase shift. So sine waveform, I will going to draw that one. You will going to understand. Yeah, okay. So input waveform I will going to draw. So input here is a function generator used to. You will going to give that one input. So input I am giving sine waveform I am giving. Yes. Then output. So output is a you will going to square waveform is produced. But where you are going to give the input? Minus terminal. So minus terminal means 180-degree phase shift. So square waveform. So here. Okay, square waveform is coming off cycles. Okay, then that's all. So like sorry, you will going to equally, you will going to write it equally, you will going to draw. So this is about the yes. See 180 degree. Here is a plus 50 means okay. Here is a minus. So just 180 degree reverse. Okay. So here is a minus means so I want to connect it as a plus. So like it, the waveform it will going to continue. That's all. Suppose I will going to connect it this function generator on the plus terminal means. So what about your output waveform? If I will going to connect it into the plus terminal means my output waveform will come like so here like it is like without any 180 degree phase shift. Like my waveform will come. Okay, coming to the point. So function generator you can connect it here. Okay, function generator you will going to set the frequency. So frequency and then time period is inversely proportional. So 1 kilohertz frequency I have set about the function generator input, and then output is a square waveform is produced. So that's all. So this is about the okay Schemitt trigger circuit. Sine waveform is the input, 1 kilohertz is I will going to set the frequency, and output is a square waveform. Okay, here is a minus input, so I will go to 180-degree phase shift. Okay, so the next circuit what we will going to see about the zero crossing detector. Zero crossing detector. So what is a zero crossing detector? You have seen that one. It is open loop system or closed loop system. Comparator and zero crossing detector are the open loop systems. So here you can see that one. Okay, input is you will going to apply similar to the function generator used to. I will going to apply the input. So sine waveform, particularly sine waveform, I am giving the input. Yes, input is a sine waveform. Yes, I have drawn. Okay, what is output? Am I connected to the minus terminal or plus terminal? Minus terminal. So minus terminal means what about that one? 180-degree phase shift. So 180-degree phase shift square waveform is produced. So 180, here is a plus means here is a minus. So like it will go to just opposite, it is a produce. That's all. It's a very simplest connections. What are the connections? One function generator connected here, one resistance you got connected. Okay, so this point you will going to connect it to the ground and apply the plus VCC, minus VCC, and then V naught. So pin number normally 2 for the minus, pin number 3, pin number 6 is output terminal, pin number here is our VCC means plus 12 volt, pin number 7, pin number what is this one here output so minus VCC, pin number 4. So how many pins you are using? 1, 2, 3, 4, 5. 5 pins are using. That's all. So this is circuit number 2. These two we're going to see. Okay. So I will show you. Welcome all of you. Today class you are going to learn about Schemitt trigger operational amp. So I will going to show you this video already uploaded in that WhatsApp. You will not WhatsApp, that YouTube. You will going to use. So what is the Schemitt trigger? It's a closed loop system. So here resistance used to I will going to connect it. Okay, here what is you can see here I got connected for the function generator. You can connect it. You will going to get you will going to apply 1 kilohertz or 2 kilohertz. You will going to give. And then how many resistance? 1, 2, 3. Only 3 resistance are used in the entire circuits. Okay, see you will going to connect it here. On function generator input here you will go to plus terminal you can connect it, minus terminal you can ground. So resistance similarly this point you will go to ground and output is ERO. So 1 plus is connected to the 6th terminal, minus is connected to the ground. Okay, then as it is you will go to make the connections. Plus terminal to the resistance, resistance to that minus, and the 6th terminal is connected to that one resistance. Resistance is connected to the pin number 3. Similarly from the point we will going to connect one more resistance to the ground. So this is a Schemitt diagram. So you will going to apply for the square sine waveform as an input. You will going to get the square waveform as an output. Where I am going to apply? Am I apply for that plus terminal or minus terminal? Either based on that one in phase or 180-degree phase shift. Okay, it's a clear waveform is showing, circuit diagram is a clear circuit diagram is showing. So I will going to make the connections. So I will show you. See the waveform. So I will going to give that one input is a minus input due to that one 180-degree phase shift. So 180-degree phase shift. So sine waveform is an input. So say same phase shift. Okay. So function generator, actually if you have see the function generator, here you will go to frequency setting the knob available. So you will going to set that one, either you want to vary from the 2 kilohertz or 20 kilohertz like the multimeters. So here is the adjusting knob. Okay, if you want to fine tune, so I need 1.6 kilohertz, you will going to vary to, you will going to set. Okay, next one is this is a waveform. Which waveform you want to take output from the function generator? I need sine waveform. Press the sine waveform. This is the output terminal of the function generator. It is coming as an output. That's all. So okay, so I'm set it as in for 1.5 kilohertz like. Okay, then you have see the waveform. Okay, you have see the waveform. Okay, one positive cycle means 180 degrees shifted, so square waveform is produced. Negative is a similarly 180-degree phase shift. So like that's all. This is a square waveform is produced output. So segmented trigger circuit is nothing but this is the only. So make the connection as per what I said now. So connected that once. Okay, to 2 terminal for that minus, 3 terminal for the plus, another 6 terminal for that output. Another one is a plus VCC minus VCC. So only 5 terminal for that operational amplifier. Plus VCC means okay, that is you can connect it to the pin number 7. Another one is a fourth terminal is a what is the fourth terminal? Minus VCC. So you will going to watch this video. Okay, I have connected. That's all. So this is a connection of that one, very simplest. So I'm explaining the step by step of the connection also. You will going to watch this video. Okay. So properly cable should be in proper, then only you will going to get the output of the waveform. So even I have vary the frequency, so 1.5. So after that I am going to varying the frequency. If I have observed it, So varying the frequency. What about the similarly your sine waveform? It will going to go the reflections. So your sine waveform is a okay. That frequency is inversely proportional to the time period. Okay. So your sine waveform, you have see that one. Yes. So now I have started two variations. I will show you. See, I have varied on one side automatically. See that one. Okay. So frequency values. So inversely proportional time period. I am going to vary the frequency. So the input waveform is varied. Based on that one, output it will going to produce. Okay. Okay. So 800 Hz. What about that output of the waveforms? That's all. So this is about the segment trigger circuit diagrams. So the next one is a zero crossing detector. So once again I will go show you the diagram. So zero crossing detector is one of the open loop systems. Open loop systems means the output is not connected to the feedback to the plus terminal, neither plus nor the minus. So output is not connected to the input. Output is not connected to the input. That's why it's called open loop systems. So here as usual I am going to give the source where I am going to give as your wish. Either you can connect to the minus terminal or plus terminals. So in that one I have show you both also connected to the minus as well as plus. Okay. So source is connected. Okay. Then here you have see that one your output waveforms. So I will want to show you. So this is circuit diagrams. It's a open, no, it's a segmented. Yes. So first one I will show you the segmented trigger circuit. So segmented trigger circuit, what is the diff from that one? The resistance only you can remove. That's all. Very simplest circuit diagram. Zero crossing detector. The output, okay, I mean a feedback resistance. The output is connected to the input through the resistance, that is called a feedback resistance. In that one I have removed the feedback resistance. So in the above circuit, I just you will going to remove as it is. So remove the feedback resistance 9.1. So just you will going to remove. Then you will going to get the zero crossing of the detector. You have see that one, that's all. So I have removed the resistance. It's a zero crossing detector because it's a open loop system, closed loop system to open loop system. You will going to make the circuits. Okay. So similarly same sine waveform, square waveform, 180-degree phase shift. Yes, you have see that one. This is a waveform. So sine waveform, 180-degree phase shift. Okay. Square waveform is a produce. Okay. Yes. So sine waveform, 180-degree phase shift, square waveform is produced. Okay. So as usual I will going to vary the that knob. I will going to vary the knob. See the result waveform. Yes. So automatically result waveform also it is varying. Okay. That's all. So this is about the zero crossing detector. Very simple. Output feedback resistance just I have removed. Okay. That's all. So this is about the zero crossing detector. Even why we want to change the input source? See here I have changed the input source. Instead of the minus, I have changed the input source. If I give the input source to the plus terminal, output is, what about the output? It is a in phase, not 180-degree phase shift. So you have see that one. So in phase output waveform, just so source is I will going to yes, see that one input. Okay, here is a positive half cycle, my output is a positive, so my output also positive. So my input is a positive, output is a positive. So negative of the input, so due to the negative, that's all. So what I did, function generator is connected to the plus terminal. Plus terminal means it is a non-inverting terminal. That's all over. So this is about the zero crossing detector of the input sources. We will going to give that one. So even that one followed by connection diagram, I will going to explain how to make the connection diagrams. So you will going to understand about that one connection diagrams. Okay, over. So this is two experiment is so far we have touched about you. The next one experiment is this is a make you for that one. So before I will going to explain you, I will going to make you for that disconnected. Okay, you can join me for that